Okay, let's continue with section 6.6 on logarithmic and exponential equations. We're on our example of solving these, and we're on part B from example 1. And here we have a log base 4 minus a log base 4. So we know we can write that as a single log. So we'll do that first. So that's log base A of m minus log base A of n equals log base A of m over n. So now we see we're not going to have a log equals log strategy. This is going to be a definition strategy. So a to the y equals x, right? Our base 4 to the 1 equals h plus 3 over 2 minus h. Right? Okay, how do you solve that? Well, we'll multiply both sides by 2 minus h, right? H plus 3 times 2 minus h, both sides. Of course, it'll cancel there, and we distribute. We have 8 minus 4h equals h plus 3. Solve for h. Okay, subtract h from both sides. I get 8 minus 5h equals 3. Subtract 8 from both sides. Negative 5h equals negative 5, so h is positive 1. Is that in our domain? Go back to the original. 1 plus 3 is 4. 4 is greater than 0. 2 minus 1 is 1. 1 is greater than 0. So we're good with that one. We'll keep that solution. Okay. Here we have log equals 1 plus log. Okay, so what are we going to do? They're both the log base 10, right? Common log. Well, let's subtract it from this side. Could we use log equals log? No way, because of this 1 right here. We'll never be able to get rid of that 1, so we can't ever write this as just log equals log, because then we'll have plus 1, and that doesn't work. So that strategy is not going to work. We're going to need to try and use the definition. So we have the log of 1 minus c minus the log of 1 plus c equals 1. So now we'll combine those into a single log and use the definition, which means, like we just did, change it to an exponential. So this is the log base 10 of m, 1 minus c, over n, 1 plus c, equals 1. Change it to an exponential. What's a? 10, right? The base is a. 10 to the 1 equals 1 minus c over 1 plus c. Multiply both sides by 1 plus c. So that it cancels there. And we have 10 plus 10c equals 1 minus c. Add c. 10 plus 11c equals 1. Subtract 10. We get 11c equals what? Negative 9. So c equals negative 9 over 11. Okay, is that in our domain? Well, what's 1 minus negative 9 over 11? That would be 1 plus 9 over 11. This would be a positive number. So we're good there. And then 1 plus negative 9 over 11. Do we still get a positive number? Yes, because 1 is larger than this, so we'd still have a positive number, and that's what it has to be. The argument has to be greater than 0, and 1 plus negative 9 over 11 is still greater than 0, so negative 9 over 11 is our solution. It works in our original logarithmic equation.